Welcome, everybody. We're going to talk about how to improve your Power BI reports with DAX. First, silence the cell phones, which unfortunately includes me. OK. There's a reason why there's a slide to silence the phones, also for the speaker. Explore everything PASS has to offer, but I guess you have seen this slide a few times. Welcome, everybody. I'm Alberto Ferrari. I work with Marco Russo at SQLBI.com. What we do, we mainly write books, provide training, provide consultancy, work with Power BI analysis services, tabular, and the DAX language. Everybody here knows DAX, or let's put it as a question. How many of you know DAX and use DAX every day? Nearly everybody. Perfect. Now, the topic of this session is quite different than the kind of session that I used to deliver. I typically talk during session about the raw context, the filter context, the theory. You need to learn DAX. DAX is simple, but it's not easy, all this kind of stuff. Whereas for this session, I wanted to do something completely different. So no best practice, no theory, no filter context anywhere, just a lot of DAX. And the topic, what I want to show you is some creative ways of using DAX to improve the quality of your reports. Probably not all what I will show you will be new to you, but I think if at the end of a session you go out with one or two ideas that you can implement today on your report to make them better, then that's just the goal of the session. So we don't have slides, so there is no theory, therefore no slides and no explanation, just a lot of demos, and we will run through DAX code and ideas to understand how they work. So that was the last slide, and we can start looking at a report. The first feedback, is this size good enough for everybody at the bottom? Can you read that? Cool. Now, we build reports. I'm not a great guy at building reports. That's not my job at all. Once the number is computed, I'm happy, and somebody makes the report better. But nevertheless, it's useful to mix reports and DAX, trying to focus on what you want to convey, what is the information that you want to provide in the report. For example, here you can see I have a slicer on the top, slicing by geography, and I have the sales amount and the growth against the previous year. So I can slice and look at different values. Of course, I need to have at least 1 year selected. Now I'm looking at Italy, but I can just remove this slicer, and I have a long list of old reports. But even if you look at only one country, when you look at the report, you are typically searching for some numbers. So you expect the user to find useful information. And if we only focus on providing the numbers, so the numbers with the results, you know what happens. You provide data to users, to 10 different users, and they come out with 10 different conclusions. This is not what we want our reports to talk about. So one thing that might be the first useful idea is to already give the conclusion to the user. Whenever I see growth, it's very likely that a user starts to search for what is the best store, what is the worst store, and how are things, what is the content of my data. So the first thing that you can do is build a measure in DAX that already provides the relevant information to the user. Whenever you make a selection by year, continent, country, region, or whatever, you create just a giant label that tells you what the best store is with the amount of the previous year, the amount of the current year, and all relevant information. In this way, if users are interested in going into details, they can go and look at that. But if, on the other hand, they only want just the conclusion, they can read it in plain English, and this helps in driving the correct conclusion. Of course, the measure needs to be completely dynamic. Therefore, if we go to France, it will show a different value. Hopefully, we have multiple stores in France. And if you just clear completely the selection, then it will tell you it's still Contoso store. OK. It will tell you the highlights against the complete report. How does this measure work? It's called commentary. Let's reduce the font a bit. It's still readable at that size? Yep, cool. Now, how do we compute this expression? We use a lot of variables, which help a lot in understanding the flow of a complex expression like this. First of all, we store in a variable the top one store name ordered by growth. So this results into a table containing store names, and that table might contain one row, but it might also contain multiple rows. Top n is never guaranteed to find only one row. If there are ties, they will all be in the same table result. Then, once the variable is here, we use it to compute further variables, and that's already the interesting part from the DAX point of view. You see that once we have a table that contains a store name, we can use it as a filter in Calculate to compute the growth for that store only and format it as a percentage. Remember, at the end, we want to show a description, therefore a string. That's why we format everything as a string in order to then compose the final result. With a similar technique, we compute the sales amount for only the best shops, and then the sales in the previous year. This is, again, the same pattern, sales amount for the best shops, but with same period last year in order to retrieve the sales of the previous year. Then, because it might be that there are multiple shops because of ties, we count how many shops are there. We decide to show the best shop is or the best shops are, depending on the number of shops. And then we build another string, the best shop names, that contains the concatenation of all the shop names, potentially separated by a comma. If there is only one, of course, there will be only that name. And finally, we prepare the result. So the best store is with a growth from previous year sales to current year sales and so on. And the result is just neat. It shows with a highlight the relevant information. This is especially useful for reports that only need to provide one highlight, or if you plan to publish these reports and send them like PowerPoint files or send them in different formats, they already contain conclusions, and then the user might decide to go further. This technique of using labels in order to show relevant information can be used in a lot of different scenarios. Here we are using to provide already the conclusion, but another scenario where it is useful is when you have slicer like this one, and you select some values. Let's say that we select France, Germany, and Italy. As soon as you go away from the slicer, all what you see is just multiple selection. You no longer have any idea about what is being filtered. In this specific report, we can see that from the matrix. But as a general idea, when you select items from a slicer, you lose the visual representation of what has been selected, unless you build a giant slicer with a lot of space that already highlights the selected values. So what you can do is build a label where you can do multiple selection. Here, for example, I have multiple selection for the country, and I also have multiple selection for the brands. But by looking at the matrix, you have no idea which are the brands that you are looking at. So it might be interesting to build another giant label that highlights the selection made by the user, showing all the values one by one. Building this measure is not that hard. At the end, if you look at the content of this measure with dump filter, it's something like 525 lines of code. And I mean, is there anybody who would be happy in writing 500 lines of code in order to don't lie? Oh, but just because he raised a hand, you need to think that, I mean, this is a useful feature. It would be useful to be able to write this code. But the guy who had this idea, who is right now saying, I would be happy to write 5 lines of code, is so lazy that decided that, no way, I will never write 500 lines of code. Instead, what I can do is build an engine that writes it for me. And that's exactly what DAX Studio does. If you need that, or if you want to show a label like this one, you don't need to write all that code. You simply open DAX Studio, you connect it with either the analysis services or the Power BI model you are working with. Right now, we connect with my report. And then when you right-click on the model, you can define the dump measure for one table, for data, or define the dump measure for all the tables, which is what I have done here. And as a result, it returns our 526 rows of DAX code that does everything for you. Then the last step, and this is the amount of work you need to do, is just to copy this code, pass it into a measure in Power BI, and then use it. The only thing you need to be aware of is that the dump measure references mainly all the columns and all the tables in your model. So as soon as you change anything, like deleting a column from a table or modifying the metadata, it will stop working. But it's not that hard. You can simply go generate it again, store it in the model, and make it work. Moreover, we use as a format this, which is a very simple format. You feel free to modify and change it the way you prefer. I find it personally very useful, maybe not for the entire model because showing everything is not so useful, but for the relevant columns that you put in slicers, adding a label at the top of report that says we are showing data of these brands and these months is useful because it helps users understanding what they are looking at. The standard that is used in the dump filter measure, it's kind of a simple one. You see that for product brand, we show Contoso, Fabricam, and for the calendar year, we show calendar year 2009, 2010, as a list of concatenated strings, one after the other, which is the most common way you can produce this kind of reports. But there are scenarios, specifically for the date or for some ranges that you might have, where you can use a more compact representation. That is not generated by DAX Studio. You will need to do it by yourself. But imagine, for example, that you want to show which month have been selected. So here, again, with the month, we selected February, March, and then May, June, July, August, September. If you represent that only as a string, it will be a list of a lot of months, which is hard to read and understand for human beings. A better representation is to show that in ranges. And we show that you have selected from February to March, and then from May to September. Of course, we need to make it in a way that if we remove, for example, July, then it shows 3 different ranges, February to March, May to June, and then August to September. In this way, it's easier for users to understand which ranges you are looking at. Doing it requires, of course, some DAX code. It's not that complex, but it's worth taking a look and understand how it works. Let me zoom in a bit. How does this label work? Well, first of all, we retrieve the month numbers which have been selected. So selected month numbers only contain the number of the month. It does not contain the name, only the number. And that is useful because we will need to iterate and do reasoning based on the number, but then we will need to concatenate strings. That's why we have a second variable, month and names, that is the same expression, but now it groups it by month number and month. Month contains the string. Then how do we compute the result? The idea is quite nice to see because we iterate month by month on only the months that have been selected, and for each month we need to know if the previous month was in the list and if the next month will be in the list. If the previous month is not in the list, it means it's the beginning of a range. If the next month is in the list, it means that we are in the middle of the range. If the next month is not selected, this is the end of the range. So by knowing this information, you can decide what to do. First, you take the month number. Then you check if the current month number plus 1, that is the next month, is selected. The current month number minus 1 is selected. And then this expression basically outputs the month name plus the month name if it is not in the middle of a range. So for the first and for the last, it always outputs the month name. And then it appends a dash or a comma, depending if you are at the beginning or at the end of the month. At the end of the entire calculation, there will be a final comma, which happens to be at the end of the whole string. And this is what the left of result gets rid of. It's not useful to spend too much time learning and understanding all the details of this measure, it's useful to know that if you need to show a range, you can do that with a string, providing a very nice human representation of this list so that people can read and use it in a seamless way. Then, again, let's go back to the idea of driving the user to find what is relevant and what is interesting. This is a very simple report. It just shows by month and by year the amount of sales. If you are looking at it, evaluating, for example, performance of brands, performance of stores, or you are searching for relevant information, the first thing that at least come to my mind is, well, let's search for the best and the worst values in this list. So I want to highlight the best and the worst in the range that have been selected. You can use conditional formatting to do that, highlighting the values, but that will produce a wide range of colors, so you need to search for the darkest or the lightest one, and that takes some time. DAX, again, comes useful, because if you are searching here for the best or the worst, you can easily build one measure that returns you the best, one measure that returns you the worst, and then you can search for it using a DAX piece of code. So what I did is I created one measure, monthly color, that does exactly this job. First, it creates a variable that contains the values of the year, month, and then the sales amount for that year and month. Therefore, the monthly sales variable will contain the month and the amount of sales. The all selected, which is the calculate modifier used here, is needed because the measure will be computed in every cell, but for every cell we need to compute the entire range. So we need to go outside of the current filter context and expand it. I promised to myself that I would have not said filter context, and I did it anyway. So basically, the content of the variable is exactly the content of this report. Then what do? We need to search for the maximum value. So we just do a max x over the monthly sales of the sales variable. We have computed it once, and then we use it through an iteration the second time. And we do the very same for the minimum value. So max monthly sales and minimum monthly sales contain the minimum and the maximum. The thing is, we have the values. So now we know the value of the max and the value of the min in the entire range. The last step is to compute the sales amount for the current cell only, and then this switch simply checks if the sales amount is equal to the max, we return 1. If the sales amount is equal to the minimum, we return 2. So we just return 1 or 2 numbers. How does it come useful? Well, once you have this measure in place, which is not extremely useful because if we remove sales amount and we just take the monthly color, you see it just shows 2 for March and 1 for 2008. But we don't want to show that this way. We still want to show the sales amount and get rid of the monthly sales. Instead, we use conditional formatting on the sales amount. You see, if we can choose the conditional formatting, for example, of the background color. And even though we are used to use for conditional formatting the same value that we are showing in the report, nothing prevents you from using a different measure to choose the conditional formatting of a measure. Therefore, we are not using the sales amount to format the sales amount. We use instead the monthly color. So we just go to highlight minimum and maximum, we choose the monthly color, and instead of using a color scale, we choose a set of rules. When the value is 1, not 1%, but exactly 1, that means I don't remember if it's the minimum or the maximum. Let's say we color it in red. Whereas when the value is exactly equal to 2, as a number, then we color it in a different way. We don't have green, but this works the same. And as soon as you click OK, you see that the report immediately shows you what is the maximum value and what is the minimum value. So the maximum now is in red, and the minimum is in green, or kind of. And of course, this works no matter what filter you do. You change the filter, and the spot changes its position, moving the eyes of the user exactly where you want them to be. It's, again, neat, simple, and it gives you an idea that using DAX, I mean, it's not using DAX. This is not genius DAX. It's just simple DAX. But the important thing is to use DAX to improve the report. Yes? One thing that I forgot to mention is that I don't hear very well. So I need you to talk very loud, as if I was old. You mean the foreground color?
Yeah, so like the 39.8 would be green, and then the 39,000 would be red.
Okay, the answer is I have no idea.
Okay, we didn't
But we can choose, I guess.
we ended up hiding the field, and then we basically had.
But if you go for the font color, which is based on by rules, based on, again, the highlight minimum and maximum monthly color, and if it is equal to 1 as a number, we color it in yellow. Yeah, seems it's working. So you can color also the format code.
We were basing it on whether or not like a number was above or below some threshold, so I imagine it would just be
Yeah, I mean, if the business logic you want to put becomes more complex, it's just the measure that becomes more complex. Then I've seen also people using the measure to return the actual color, which is then used to with the hexadecimal code of the color. I think you need to choose. So I would put the entire business logic in the measure. If it's greater than, minimum than, you define a set of values. And then in the report, you choose the mapping between the value, which has a business meaning, with the color, which is something that you can change on the fly just by modifying the report. Okay? So highlighting minimum, maximum is, again, the first idea, but then it's open to you. You can highlight and identify the value that you want the user to focus on and just move a spot on the screen, drawing the attention of users exactly where you want it to be. And you can use it for even more complex calculations, helping users in finding where to look at. Because again, we are used to show in a report values, and we expect the value to tell everything. But actually, sometimes a value hides something behind it, and if you don't drill down and if you don't explore further the data, you might miss important information. Instead, conditional formatting can be used by the means of using a different measure than the one displayed on the report to convey additional information. Let's see that with an example, not this, which is the last one. This report, again, it's just an example, but the idea is that the report helps in identifying the periods, the month in this case, where there are spikes in sales. So you might have a regular trend with sales, but 1 day, 2 days, 3 days in the month might have a spike, or in the case of different measures, they might drop below a certain limit. So finding those dates requires you to scan at a different granularity this time the current filter, searching for values which are outliers. And how do you find an outlier? Well, the idea is that you take the standard deviation, you take the average amount of sales in the period, you compute the standard deviation of the sales, so the average deviation of days for that period, and then you let the user choose how many sigma you want to analyze. So you start from the mean, and you might highlight month where the sales amount, you might highlight days where the sales amount is greater than the average plus 1 times the standard deviation, 2 times, 3 times, 4 times the standard deviation. Of course, if you use only one time the standard deviation, you see nearly all the months get highlighted because there are, of course, variations in sales. If you go for 4 times the standard deviation, only 1 month has this spike. What most people use in this kind of analysis is 3 times the standard deviation. And because we are talking about sales, so numbers are never negative and are quite always positive, we just look for positive increases. So we don't look at drops, we just look at high amount of sales. Otherwise, the numbers would not be so interesting to see. How do you compute that? Now, the thing is the calculation can no longer be done at the same granularity. Even though we are looking at a month, we want to do the calculation at the day level. So we need to do the calculation day by day, compute the average, compute the standard deviation, and then count the number of days which happen to be above that limit. And the measure is, again, it's long, but it's not complex by itself. How do we compute it? First of all, we retrieve the dates because we have a number of days that we want to scan, and the first thing that we do is we define the granularity of our calculation. So we compute the values of the date, but we remove any filter from the date except from the month, because the calculation we want to do is month by month. We don't do that day by day. We highlight the number of days, but the calculation happens at the month level. And this is a bit more evident if you look at this chart below that shows the amount of sales, and this is the standard deviation, the average that we use. And you see that every month has a different average, so that we highlight sales that in that month have are higher than the average plus 2 or 3 times the sigma. Once you have the monthly days, we have detected the dates that we are interested in scanning, we need to compute the average over that period. And that's as easy as doing an average X over the dates of the sales amount. We compute the standard deviation, which is, again, a standard deviation over the monthly dates of the sales amount. And finally, we want to let the user choose the number of times the standard deviation need to be multiplied. So the user chooses 1, 2, 3, 4 through a slicer, and we need to read that information from this table. Now, this table contains 2 values. One is the string that we want to show in the slicer, because it contains greater than 3 times sigma, but then we want to get the number 3 out of this string. So to do that, we created a table. It's easier if we look at that from here. That contains 2 strings. The description we want to provide, and then the number that we want to use to multiply the standard deviation. The user will select the string, but we will want to retrieve the other value. But the thing is, when the user selects one value from the slicer, it applies a filter to the table. Therefore, only one number will become visible in that table. And we can check it. Inside our code, we can use the selected value function. Selected value checks if the factor contains only one value because of the filter coming from the slicer, then it retrieves that value. If, on the other hand, the user did not select anything from the slicer, instead of blanking out everything, we use a default value of 1. So we define the amount of sales that should be used as the limit, and any sales that is above that number will be counted as an outlier. The next step is computing the limit, the average sales plus the standard deviation multiplied by the factor to define the outlier. And then the result will be a number that simply filters the dates where the sales amount is greater or equal than the limit. It's relevant, if you ever implement this with you, that here we are using values of date, whereas for monthly days, we are using calculate table values of date for all date in the month. This will contain the entire month, because we want the average to be over the entire month. But then when we count the period, we want to do that for the selection that is currently being present in the report, whatever it is. So that's why we don't use monthly dates here. Instead, we use values of day data so that it will work also at the week level, at the month, at the day level, or at whatever level, still computing the average over the entire month. And the result is just here. So you can see that the months which are highlighted are several. Let's go for 4 delta. So we have only 1 month which is selected. And if you click on this report changes. In this report, I have just plot the amount of sales, and this is just showing the value of the limit. So that it's very easy looking at this report when it did happen. So you have now 3 points which are above the maximum, and it's very easy and neat to see the value. When you plot it at the year level, it's not so sexy because it contains a lot of values. But as soon as you drill down at the month level, it shows in a very nice and graphical way how to show the number. Okay, and then, of course, here I just put some other values just to describe the algorithm and nothing else. But again, what we are using here, the conditional formatting for, is not to format the current measure, but instead to tell the user, hey, if you are searching for outliers or for days with a lot of sales, you need to search here, 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 and here. And then you start drilling down and understanding more about the information. And I think this is an important thing. A lot of times we show a number without telling the user, hey, it is worth going further and discover more about this number. If you just show an average or if you just show a sales amount as a total, it might be that the relevant information is hidden below and you should not expect the user to search them by himself. Another important thing is that you see here we are showing sales amount sliced by date. So this is just a line chart that is showing the sales by date. And that's fine. There is nothing bad in doing it.
Marco, would it be really complex to add the worst days of the month to this? Like, just to look at your previous one.
Yeah. I need to repeat the question. Would it be too complex? Alberto, by the way, but that's not an issue. You have no idea how we got used to that. So it's totally fine. Unless it's my wife calling Marco, it's fine. Anyway, I need to repeat the question for the record, which is, would it be hard to also show the lowest values? No, I mean, it's just a matter of, this is highlighting the highest value just because we're talking about sales. And sales are never blank. When they are blank, it's because it's Sunday or Saturday. So if you want to spot also the minimum sales, you would add more complex logic to that. But if that was the temperature of an engine or something which has a variation and you want to show the maximum and the minimum, you need to find a graphical way to show that. So maybe not just one color, but showing different rules. But by using the rules as we did in the previous one, you can, for example, use scales of red to show the high value and scales of green to show the lowest values, finding a business logic that does it.
Alberto, I have a question.
Yep.
How would you go about representing this for potentially visually impaired people or being able to comply with ADA?
How would you show that and use that for people who are impaired or they have difficulties, I guess, in...
How do I know, like, for example, this selection versus the next selection versus, when I drill in and find more information, how do I transmit that specific?
Yeah. And to be honest, I don't have an answer to that. So I'm totally not an expert in how to build reports which are useful and visible for impaired people. Marco has.
Can you, depending on, do they hear with a braille or just
Usually screen readers is
screen readers? So I think that you need
Yeah.
report for a screen reader. But would it be possible to have like a CSV readout that would tell us all of the information on the screen, all of it, not just like the table, but like every piece of it and concatenate it some way?
I would use a mix of this technique and the previous one to get, if you iterate a combination of the year and month, and you filter by those that have this number that is greater than 0, and then you create a list of those year and month in a legend that you make readable. That could be the technique.
Okay. I think it's interesting. We can discuss that further. But what I want to show you now is, again, a different thing. Here you see we have a line chart that shows amount of sales by date. And in the table containing the dates, we have, of course, the month. Here you can see I have two charts. One, it is showing the sales amount by year and month, and this is showing the sales amount by year and month. They actually look the very same chart. They are slightly different just because I haven't been able to make them exactly the same size, but actually the numbers they are presenting are the same. What is the difference between the two? Well, the difference is the column that we are using from the date table. Originally, for the year month, I used the calendar year month column, which is a string containing July 2005, January 2005, the date represented as a string. And Power BI is smart enough to show the strings, which are then sorted by calendar year month number, and uses them to build a line chart which works absolutely fine. What is the problem of this line chart? Is that at that size, everything is fine. But you can start to shrink it, and you see it reduces the font, and it goes on reducing the font, also putting it in vertical, and then you reach a point where it says, you know what, because this is a string, at some point, if all the strings do not fit in my chart, then I need to remove some of them, but I don't know how to remove them, so I add a scroll bar. Now, I guess you know scroll bars in reports, they are definitely bad. Whenever you have a scroll bar, it means there is some information on the side, but I'm not going to show it to you. If you want, you need to go search for it, and maybe the useful information is exactly there, but you don't see it. You need to scroll here and there to see the information. It would be much better to be able to build a report that is able to be resized even at a tiny dimension, and everything works just fine. But in order to do that, Power BI needs to be able to understand that the column you are using to do the slicing is not a string, and the engine would not know how to reduce the number of points for strings. But it needs to be something different, like a number or a date. In this very example, we are using here a date. But we don't want to build the report at the date level, because even though we could do that, instead of using this, we could use the date here. But you see that the report is unreadable if you use the date, because you went to a granularity which is just too high. So how can we obtain the same result as going at the date level without properly using a date? Well, the idea is to create a column which serves only this purpose. It needs to be a date so that the engine will be able to resize it at any dimension, but it needs to show a month. Here I'm showing July 2007, January 2008. And how do we do it? Well, to do that, I created a new column, calendar year month, which is just computing the end of month of the data. So in whatever date you are, CYM contains the end of that month. And it contains it as a date. So it's a date that represents the end of a month. But if I use it as it is, it will just show the date, the 31 of January or the 28th of February, and so on. Remember, in DAX, you also have format strings. And in this case, for the format string, I used YYYY and then MM. And you can choose the format that you prefer. But because we are only interested in showing the year and the month, we got rid of the day in order to show that all this information is just for the end of the month. And the next step is just using it in the report. Instead of slicing by a string, you slice by a date, which collapses all the dates in a month to the end of the month, but it is still a date, so that the engine will be able to resize it in a seamless way, no matter what you do. As with anything, there are always limitations. The first and most relevant one is the number of the format strings that you have available. You cannot choose any format string. As of now, you are limited to the format strings which are provided by Power BI. But they are enough for most of the purposes. And again, the important thing here is that sometimes you cannot use a visual to obtain a specific behavior, but by adding a column or by slightly changing your model, by adding some small pieces of DAX code, you can use visuals to make them do nearly what, well, not whatever you want, but to make them behave exactly the way you want. Now, yeah, we are still in time. Another example where DAX comes useful in providing correct information to users is when you analyze sales in a period in time over several stores. Look at this report. This is showing the sales in different years for stores in Italy. There's nothing wrong with this report. It works just fine, and these numbers are all correct. But it might be the case that they are not they need to be interpreted. So why do we have different values? Can they really be compared? Actually, no, because there are some stores that were not open in 2007. For example, the store in Rome was open only in 2008, and there are stores like the Venice one which have holes. They have not been open for the entire period. So one very common calculation is to do like for like. So I want to compare the sales, but only for all the stores that have been open for the entire period. Therefore, if a store has been closed for some time, I get rid of it in the calculation. Or if it was open later, again, I get rid of it in my calculation. A human can do that, of course, but most likely, if they need this kind of calculation, they will export the data to Excel and then start playing with Excel, removing rows, redoing the calculation, and basically rebuilding your report. Or we build a specific measure, which we call same-store sales, that does the complete analysis for us. So it removes from the report all the stores that have not been open for the entire period. And of course, such a calculation needs to be very dynamic. It needs to adapt to whatever filter and selection is done. Here, if we only select 2008 and 2009, the numbers will be different. The store of Rome, which is not visible right now in the bottom report, should become visible. If I select 2008 and 2009, you see that the store of Rome suddenly appears because in the selection, the period which has been selected, it has been open for the entire period. How do we compute such a number? Well, this is just one measure, so it's not that complex. But again, it needs to be understood quite well. First of all, we say that the calculation needs to be very dynamic. It needs to adapt itself to whatever selection. So what we need to do is compute the number of years. And please note that that year is not in our sales table. The year, which is the granularity we want to use to detect whether a shop is open or not, is in the date table. But I cannot just count the years in the date table. I want to count the years in the date table for which there are sales. And so what do? We remove any filter in order to have the number of years for which there are sales for any shop. And then we join the dark side and we activate bidirectional cross filter on the relationship between date and sales. I always say that it's absolutely bad to use bidirectional cross filter unless you know what you are doing. In this case, it's only in one measure, so we have full control over it. Hopefully, we know what we are doing. Therefore, we can use bidirectional filters the right way. This computes the number of years for which there are sales. What does it mean? That if in my date table I have 10 years, but only in 3 of them there are sales, that number will return only 3, the number of years with some sales somewhere. And then we need to understand which stores have been open for the entire period. We use the very similar technique, so we compute the number of years which are referenced from the sales table, but this time we do that store by store. So for each store, we just check how many years that store was open. So filter iterates over the store, one store by store, and for each store, we repeat the very same calculation. We compute a distinct count of calendar year, activating bidirectional cross filter. Instead of having all selected over everything, now we do all selected only on the date, because we want to keep the filter on the store that otherwise would be removed. This will tell me how many years that specific store was open in the period. Now, if the two numbers are the same, then we are happy. It means that that store has been open for the entire period. All this is saved in a variable. So same stores contains the stores that were open the entire period. The final calculation is actually a very simple one, because we just compute the sales amount for the same stores. We need to use keep filters because there might be other filters which are filtering an individual stores. We want to keep those filters, but then if those filter is not present, or if that filter is filtering other stores, keep filter same stores guarantees me that only the stores which are present in the variable same stores will be part of the calculation. Again, this is useful and interesting not only when people slice by store, but it is useful to have it because sometimes you don't slice by store, so you don't have a clear information about sales here, and instead of slicing by store, I need to find, for example, the category. You get rid of this and you slice by brand. This is showing the sales of Contoso, Prosper, and Wide Importers, but only for the stores that have been open for the entire period. So it provides a different view of the information and lets you compare apples to apples in a better way. This is actually not improving the report, but it's more about providing the correct information to the user. Instead of just showing the number and then force them to understand which number need to be removed and which not, you can use that to compute numbers in an easier way. Now, if again we look at the stores, you see that some of them were open in 2007, some of them were open in 2008. Each store has a different history, a different story. For stores, for products, for any entity, you always have a starting point. But specifically for stores, at the beginning, when the store is open for the first time, you might decide to create special sales or special offers or try to drive users to buy from your store. Therefore, it might be useful to analyze the sales of the launch of the store, the first period when the store was open, and then compare different stores based on their own launch date, because not all the stores were open on the same date. But let's say the first 60 days of life of each store might be interesting to analyze and compare one against the other. Therefore, instead of looking at the sales as we are seeing here, sales year by year, we might build a different report that, again, already provides pre-computed information to the user in order to take better decision. For each store, we say, well, the launch date of Firenze was the 7th of January 2007. The sales during the launch period was this. During the first year, this was the amount. And the ratio between the launch and the first year is, again, a different number. But every store will have a different date. How do you compute such a number? Well, computing it requires, first of all, to be able to identify for each store its first sale, its first date, and then restrict the calculation to only the period which is between the opening date and the end of the selection. As we did earlier, we let the user choose the number of days of launch. So you might use only 10 days, and of course, these are the sales of the first 10 days. Or you go to 30 days, or you go to a different period like 90 days. And of course, all the numbers will change depending on what we use. For the launch days, we use the very same technique that we used earlier for the value of sigma. But how is it computed, the launch date? Here it is. Launch sales is kind of a more complex measure because it needs to do more calculations. First of all, as we did earlier with the value of the standard deviation, we read from the slicer the period that the user selected. So the user in the launch days table said used the launch days table to select the number of days. If there is no selection, by default we take 60 days, so that even if there are no selections, we still take some good value. Then we need to know the stores which are present in the current selection. We just take from sales the store key. And then we add to the stores a variable which contains the first sale. The first sale is the first date for which there are sales. You might have this information already in the store table. If not, you just compute it by checking when the first sale happened for that store. You need to remember to remove from the date table the filter, because the user might select a specific year, a specific month, or use this measure in a report that is slicing by year and month, but you don't want to take into consideration the first sale in the period, but the first sale ever. That is the opening date of my shop. Once you have the opening date, what we need to do is use this as a filter over the fact table. But the thing about this filter is that for every store, it will need to filter a different period. So for one store, it will filter one period. For a different store, it will need to filter a different period. How do we do that? To do it, we need to generate a new table that contains the store, and for each store, the list of all the dates that we want to use as a filter. So the table will contain a pair of store key and date for only the dates which are included in the opening period. Once this table is used as a filter, it will filter both the store and the date, and it will filter different dates for different stores. This is why generate is useful. Generate is not a very common function used in DAX. It's mostly used in queries, but sometimes also in measures when the complexity of the code starts to grow, like in this case. So generate iterates over the store and min data, which is worth remembering contains the store and the first data. And then for each store and data, it calls dates between that returns all the dates between the first sale and the first sale plus the period. The result is a table containing store and data for all the dates that we want to consider. As usual, complexity is all above, because then the last step, computing the actual result, only requires you to do calculate sales amount, and as we did earlier, we keep the previous filter, plus we add a calculation for store and sales. So we use our store and dates table as a filter in order to restrict the entire calculation to only the current period. And the result is that no matter what selection happens in the year, you see that we have, this is just computing the launch date, but launch sales contains the sales of each store of the current period. You could obtain a similar result using a SumX and code which might be a bit simpler. The advantage of using this approach is that it's going to be quite fast, even in complex scenarios. Yep, there was a question? Can I ask you to speak a bit louder, please? Otherwise, I really don't hear you. Okay, So the question is, the measures are complex, how are they gonna work in a large data sets? And you know the answer, it's always the same, it depends. It depends on the specific measure, and it depends on what do you mean by large data set. Each measure has its own complexity. And unfortunately, it's really, really hard to answer you for all of them, just because I don't remember them. But the complexity of this measure specifically is just, this is retrieving only the store key, this retrieve for each store the first sale, and this only computes a dates between. So mainly the complexity of this specific measure depends on the number of stores. So the more stores you have, the slower it will become, but up to a few tens of thousands of stores, you should have no issue at all. And then the number of days that you use, because the final table will have the cardinality of the store plus the date for all the dates that you use as a filter. For small number of stores and small periods, you shouldn't have any issue. That should be very fast. That measure. All the other ones, I honestly don't even remember the code, so we need to look at them one by one and check how they work. But that shouldn't be slow. It should be good enough. Okay. One still demo that I want to show you is about the usage of the waterfall chart to show growth and drop in sales. But again, let's start from the beginning, and then we look at that one step at a time. First of all, why do we typically use the waterfall chart? The waterfall chart it's just beautiful. I like the waterfall chart because it conveys so much information in a very clean and precise way. But the reason why we typically use it is because you have sales in 1 year, sales in the next year. There is a difference between the amount of sales in the previous year and in the current year, and you want to explain this difference by analyzing the growth and the increase and decrease of different categories, for example, different colors, different brands, different stores. So what is this chart telling me? Is that the amount of sales in 2007 is 11 million, the amount of sales in 2008 is 11 million, here I lost 500,000, so it's 11.5 million, and this is 11 million. The difference is 500,000. But it's not generally distributed over all the products the same way. Some categories, home appliance, increased their amount of sales. So if you just focus on home appliances, actually the sales in 2008 are higher than the sales in 2007. The same happens for TV and video, whereas other is quite stable. Computers dropped. Cell phones dropped, and cameras and camcorders dropped. So basically, people are no longer buying technology, they are only buying home appliances and television. So this lets you break down one value into what increased and what decreased over time. And if you want to build such a report, you just start using the waterfall chart, and you only need to provide the category, the value that you want to use, and the breakdown that you want to do. So we are looking at sales amount, the difference year by year, breaking it down by category. The thing is, sometimes what you want to do cannot be broken down in such an easy way. So I don't want to do the breaking down by category, but I want to use a different business rule. For example, I have products that are constantly introduced in my shops, and I have products that are constantly sold. So I have a set of new products. Every month I introduce new products. And then I have a set of products which are evergreen. They always are sold. And I might create calculations like this matrix that shows month by month the amount of sales of new products that have been introduced this month, and returning products. By returning product, I mean a product that was introduced earlier and it is sold here not for the first time. And then I have the amount of sales. I would like to show to use the waterfall chart to build a calculation that shows that this is the amount of sales in 2007, this is the amount of sales in 2008, but there was an increase in the sales of new product or a decrease in the sales of new product, and again, an increase or decrease over the returning products. What's the problem? The problem of building a calculation like this is that I don't have a category to use as a breakdown, because the calculation of new and returning product is done through measures. I have a measure that computes a value that changes its value year over year, but I cannot categorize it using one of the columns in my table. So in order to be able to use the waterfall when what you want to do is categorize by a measure, we need to introduce a dummy table that will let me slice these numbers as if they were categories. So what I did, I introduced in the model a table, new or returning. New or returning is a table that I just created that contains only two strings, new or returning. So it's a very simple table that is not even visible to the user. Now I left it visible because we want to discuss it, but in the real world, nobody would ever see that this table exists at all. And its goal is to replace these two measures. So I created another measure, new or returning sales, that depending on the value of the new and the product states, returns the new product sales, the returning product sales, or the sales amount. So if new is in the filter context, it returns the new sales. If rate is in the filter context, it returns the returning product sales. Otherwise, it returns the sales amount. And by default, this time, current status is all. So if there is no filter, the result is all. What is the purpose of this measure? Well, in this matrix, I can get rid of sales amount, returning, and new product sales. Instead, I put new or returning sales in the values, and this is just showing the sales amount. But now I will be able to slice it using this column. So if I use this column and I put it in the columns, you see that now I have only one measure that can be sliced by different categories and shows the new sales or the returning sales. And the advantage of using this slide, of using this column, is that now I can use it to do the breaking down of sales by new and returning sales. So you can simply go here, and instead of using the category, you take the new returning sales, and you do a breakdown. No, you need to use the breakdown by the new or returning sales, one step at a time. Click. Then the product states as the breakdown, and the measure that I want to use is not sales amount, but new or returning sales. Now, this way it's not visible. That's why I already prepared the waterfall as an end, because you need to set the 0. Otherwise, using this calculation becomes really hard. But this shows you the amount of sales in 2008, the sales of new product, the sales of returning product, and this leads to, no, this is by month. So month by month, I show the new product, the returning product, and the sales amount of February. Then there is a drop in both. Then there is an increase in both. And there are months, like here, where the new product have a slight increase and the returning product have a high drop. Again, it's the usage of a visual not exactly for the purpose it was designed to, but for something slightly different. Keep in mind, the waterfall chart used in this way is not yet perfect. Here, the main problem is the waterfall chart by default, not by default, you cannot configure it, shows first the increases and then the decreases. So it's not that the column with new is always the first one, or the column with old is always the second one. It depends on which one is increasing and which one is decreasing. So the increasing one will be also always the first, the decreasing one will also always be the second one. That's a current limitation of the waterfall. But if enough people start to use it, then ideaspowerbi.com will help us obtaining a better behavior, or at least be able to change the sort order also for the waterfall. Okay. That was the last thing that I wanted to show you. Let's just make a very, very quick recap of what we have seen. The entire idea of the session was to show you different ways and different ideas how to compute, how to use DAX to build reports that might have interesting ideas inside. So we've seen, first of all, how you can build a commentary, a description of the interesting findings that are present in the report to drive the user to understand better what you meant. Using a similar technique, the commentary needs to be done by hand, and you can use it to use the dump filter. The dump filter lets you understand out of multiple selection, so information which is hidden inside the report. The dump filter created by DAX Studio lets you generate the set of filters. Also, when you are learning DAX, it is useful to use dump filter to understand what the filter context is in specific parts. At the beginning of the learning process, it's quite useful. Then we went to a variation that computes the different month names. And finally, we used DAX to highlight the minimum and the maximum out of a value, or whatever business logic is useful to highlight the important part of your report. Then we detected anomalies in the report. So again, we used conditional formatting to highlight cells where the value is higher than the average in that month, or to count the number of days which are average than that month. Then we computed the same store sales, comparing apples to apples, so comparing like for like instead of just producing a simple report. And we looked at the launch period. So for each shop, you compute different periods. I've seen this technique used a lot of times in healthcare, for example. You want to look at the improvement of patients over time, even though patients come in different points in time. So each patient has a number of visits, and you want to compare the growth in the health status of that patient over time, but every patient, of course, has a different starting point in time. And then the monthly line charts to avoid the nasty effect of having scroll bars when you reduce the size too much. It's kind of a nice trick that of adding a column containing a date instead of a string in order to be able to resize columns the way you prefer. Last thing that we have seen is how to build waterfall with measures instead of waterfall with categories. Basically, we use a category to show measures as if they are categorized by that category, even though they are not. It's a feature very close to what we will be able to do, hopefully soon, with calculation items as soon as they will hit, as soon as it will be easier to build them. So, what is the conclusion of the session? Power BI is not just a reporting tool. Power BI contains a lot of different features. There is Power Query that lets you change and massage your data. There is DAX, of course, my favorite, that lets you compute any kind of measures. You can use it to compute measures which are useful to produce a number, but you can also use it to drive visualization to do something different and to improve the quality of the report. Mixing them together is the key. You cannot just know DAX or know how to build the report. You need to know something of everything in order to mix them and build on top of what Microsoft offered. DAX is not just useful to compute sums, but also to compute numbers which are only useful for report. Be creative, share your ideas. I'm always curious to read and understand what people are doing with reports. Most of the ideas you see here are coming from discussion that we had at conferences and in different places with users that shown us how to build beautiful reports. So use them, use your creativity, and build interesting reports. Remember, evaluate the sessions. There's always a fight between speakers. My session was better than yours, and you are the only one that can help us win that fight. So do that, evaluate the session, and hope you enjoy the rest of the pass. Thank you.